Hi, my name's John. Welcome to another Sunday night nightcap. Tonight's nightcap is all sort of steam engine based stuff. I repack a valve off a Fowler traction engine water gauge, and I get some really badly corroded studs out of a bronze casting. I hope you find all that interesting. The Wednesday catch-up videos are going quite well. Last Wednesdays I did on lathe tailstock alignment because I didn't realise how far out my tailstock was until a viewer pointed it out, and I started to watch a video and it was a long way out. I hope you found that useful as well as interesting. It's more or less the end of the steam engine rally season now, and people are preparing their boilers for the annual boiler inspection or the 10-year inspection. This is a gauge glass valve. It's a top valve of a Fowler traction engine, and the problem with it is it's passing water, it's leaking, it's not sealing properly. So my job is to try and sort it out. It's not a normal type of tap where a lot of my taper taps. This one's a parallel one, and it has 4 strips of packing set into the bottom of the hole. The packing will have worn away over the years. The plugs are slack fit, but it doesn't need to be tight because it's the packing that seals it. So I'm going to chisel all the old packing out, repack it, test it, clean it up, see if I can make it watertight. That simply drops in there, that nut screws in, that compresses the packing nice and tight. So that's straightforward enough. This one here doesn't need much explaining really. That's where the water gauge goes onto there, and you can see that that stud there is really badly wasted away. That's definitely a fail. The boiler man wouldn't like that at all. That one there is not too bad. That one should come quite easy because I can get to the back of it with some heat. This one here will probably chop it off, weld the nut on and go from there. One consolation is it does sit fairly flat. There's a flat face there and a flat face there, so it'll be simple enough to drill them and retap them if I had to, and they're 1/2 inch width, so there'll be new studs to make for them. Quite incredible the way that's wasted away. We're going to do this valve first. You can see that's where the packing sits in there, and that's the old packing in there. It has a good chance to have asbestos in this stuff, so we're going to make sure we dispose of it properly. And we're putting modern packing in there without asbestos. Get it all out. So there is four strips of it. So the slots are tapered. I'll bring the camera in so you can see it. The slots are tapered, so as you push the packing down, it expands and pushes it tight into the valve. Quite a clever idea, but a little bit of a pain in the arse to pack, but once they're done, they're normally a really good valve. Right, hopefully you can see get the light in the right way. You can see the tapered. There they are. See the tapered slots in there where the packing goes. This is the packing I'm going to use. It's a modern stuff, graphite. And the idea is to get into that slot as best we can, and then get the valve back in. And then once you take the nut down, it compresses the packing around the valve body. We can get the valve in, it'll help to seal it in or bed it in. It's not a nice job, but it's horrible. Right, so I've got the valve in there. I'm going to put a little bit of steam oil in there just to lubricate the packing a little bit. I'm going to put a ring of packing round, tighten the nut down, squash it in and see how much packing I can actually get in there. They're actually called turns. It's a turn of packing, not a ring of packing. So oh, that bastard thing to hold it is. Right. I'm going to get a little punch and tap that down. It looks good. It's better. You see how that's going to squash that packing into those 4 slots in grip on the valve spindle. We'll get another turn of packing in there now. Try and put the ends opposite each other. It doesn't matter because it all sort of squashes together and amalgamates into one solid ring of packing. A slightly smaller punch. Starting to get a grip now. I think we'll leave it at that. There's a good 1/8 of an inch there to tighten down as the packing wears in. Won't get any more in there. I'm going to put some of this stuff in. Really is good gear. We use it on turbocharger, studs and things. It stands lots of heat. It's a good lubricant. Really messy, which is which sort of suits me. Right, that feels quite nice actually. I'll put a pressure test on it somehow. Possibly have to make something to go on there, make a flange to go on there, so I can put some pressure into it. I've made a little adapter. I've just brazed the boss into that bit of plate, clamped onto the water gauge fitting as a copper washer in there to seal it. The reason I brazed that instead of welding it was I didn't want the plate to buckle. A brazed joint like that's more than strong enough to do what this is going to be doing. We're going to carry out a hydraulic test on it. Right, so if we open the valve, that's open there, the water passes through it. We close the valve off, build some pressure up. There's 100, there's 200, there's 300, which is well above its working pressure. It is weeping very, very slightly, but it's certainly nothing to worry about. That'll pass, no problem at all. If the gland was nipped a little bit more, it would probably even stop that. I think it works at about 210, 220, so it's well above its working pressure. It'll basically take anything you want to give it, and that brace joint is not moving.